Project code ITPW32. Project title Ultra High Step Up Non Isolated Interleaved Boost Converter. Actually, in boost converter, we are differentiated into, before that, in a DC to DC converter, we have differentiated into two. One is isolated, other is non isolated. We know that in a conventional boost converter, like the circuit on inductor, switches, diode, capacitor. We're giving the input and get the output. There is no isolation in this converter. But in a non-isolated converter, we are using some coupled inductor. Coupled inductor is used in between the input and output. It is very essential to eliminate the electromagnetic interference problem. And for getting the high level of gain, the coupled inductor is widely used to get a high input output gain. In existing concept, the step-up coupled inductor-based boost converter is having a low gain, low voltage gain. Actually, the low voltage gain in conventional converter, the input is given in a inductor. The inductor having stored the charges in the inductor and delivered to the output. But in a proposed concept, we replace the inductor with the coupled inductor, and we using three coupled inductor and two switches. In conventional, we using only the one switch. Here we using the two switches. Within, we have to get the ultra high output. Ultra high output. In existing, the main drawbacks, existing boost converter have the main drawback of input current ripple is high, because here we using the interleaved converter. Before that, the interleaved is one of the type of the boost converter. Um, we are giving the one phase to the interleaved. It is interleaved, means it's separated into the two, and here two switches is used. Here we use it to get the high level output and reduce the voltage ripple also, voltage and current ripple. Current ripple reduced because using the interleaved concept. And the proposed concept non-isolated interleaved topology already said. And in conventional converter, we only get the two gain. Like depends upon the duty cycle. We give the 100 volt means maximum we get only the 200 volt. But in our proposed 20 gain, 20 voltage gain, 10 voltage is given means 2000 volt we get. It is possible. Then only it is called as a ultra gain converter, interleaved converter. In a proposed advantage, the very small input current ripple, already said low ripple because of the interleaved, and the high gain, and the leakage inductor energy also utilized, because there are many coupled inductor is used. So in the inductor, the leakage inductance energy also utilized, then only we get the ultra high output, and the high efficiency and the conduction loss also reduced. And the DC sources given to the ultra high boost converter and DC load. And here the, sorry, it is a controller. Controller is given the pulse to our proposed ultra high gain boost converter, interleaved boost converter. In a controller, here we use this PA controller. We're giving the reference voltage. In case reference voltage fixes 1000, and the actual voltage from the output is given and get a error and given to the PA controller. The PA gets some error value, tuned error value, which is given into the pulse width modulation. That pulse is given to our proposed converter. In case we change the reference value, the output also change. It is said as a closed loop system. The application, the renewable energy application mainly it is used, and the battery storage application also this our proposed converter is used. This concept is implemented using the MATLAB 2015B, and in prototype we using PIC microcontroller. It generated the pulses, and the PIC microcontroller have some program. It is fed using microprocessor lab application tool. The hardware, the mainly the switches used is MOSFET, and the transformer used to give the supply to our PIC microcontroller, because PIC having a 5 volt input VCC. So the in between the regulator regulate the 5 volt and given into the PIC microcontroller, and other passive devices and active devices are loose like diode and driver IC and the inductor, resistor, capacitor, which all form to make our proposed converter. Thank you.